Hello everyone, my name is Robert Calvert and today we'll be talking about Cribl Edge architecture. In today's presentation, we're going to be discussing what is Cribl Edge, focusing on the control plane traffic, talking a bit about fleet management, finishing with any other tips related to Cribl Edge that don't fit into the other sections. Let's start by thinking, what is Cribl Edge? Cribl Edge is a universal collection agent. You can deploy Cribl Edge onto Linux, into Kubernetes, on Windows, and also on macOS. Cribl Edge nodes are centrally managed from a Cribl leader, and they are arranged into logical groupings which are called fleets. Cribl Edge communicates with the leader node over TCP 4200. This is important to note that this is not an HTTP connection. So if you have proxies that are looking for this, they will not work with this specific type of traffic. I've mentioned control plane traffic before, and I want to revisit exactly what that is. Within Cribl, we view architecture as having three main planes. These are the management plane, which is exclusive to Cribl Cloud. This plane contains all of the operations and communications about services for organizations or workspace level. These might be instructions to provision new workspaces, create new infrastructure, or manage things relating to roles, access, and the highest level of permissions. Below the management plane, we have the control plane. The control plane is the Cribl leader level. This is where operational choices are made, focusing on things like configuration, updates, and managing jobs. The final level to be aware of is the data plane. This is where Cribl stream nodes or edge nodes actually sit, and is where the horizontal data flow and core activity takes place. For this presentation, we're going to be mostly focused on the control plane. This is the part that, as we are scaling an edge deployment, we need to pay more and more attention to. The first thing to think about in the control plane is a Cribl Outpost. This is a feature that was made available in 4.14 and will be coming generally available in 4.16. Cribl Outposts act like a proxy for control plane traffic between edge nodes and the leader node. You could have a situation where, rather than hundreds of edge nodes each making a connection to your leader node, they make connections into the outpost, and it is the outpost that manages connections onto the leader node. The key benefit of an outpost is it allows simplified networking and the ability to adopt a tiered architecture. As a result of this simplification, your networking team will love this. Rather than managing outbound firewall rules, potentially for thousands of nodes, instead you just need to focus on the outbound connections from the Cribl Outpost itself, which is a far more easy task to manage and monitor. The other architectural change that is available are connected environments. This is a feature that's been available since version 4.8.2. Connected environment's primary objective is to connect an on-premise leader node to Cribl Cloud for billing. It enables organizations to adopt the credit-based consumption model. This also has the option of simplifying or enabling specific types of edge architecture as well. So some organizations have adopted this as a method of managing their edge deployments. Under this model, we have a Cribl Cloud hosted leader node and also a local leader node running in an environment we control. We tether together those two leader nodes by setting up the connected feature. Once we have done this, all of our Cribl Edge or Cribl Stream components can freely connect into the local leader node, and that is where all of the operational control takes place. If you want to make changes to your edge environment, you would log on to your local leader node and interact at that level. Under this arrangement, Cribl Cloud is only used for billing. So if there is a situation under which you wish to set up an outpost, how would you go about doing this? The short answer is you set up Cribl Outpost to look like a mini leader node. You'll be running the same binary, just with slightly different options. So you'd run the Cribl binary with the option mode-outpost and specify all the parameters your outpost needs to connect into your main leader node. Once you've done that, you then connect nodes into your outpost, essentially making them think that it's a leader node. You do this by updating the parameters for each of your nodes themselves. The leader token that you'll be using is the leader token that will be passed through the outpost. When we are thinking about scaling a Cribl Edge deployment, it's important to also consider the impact this has on our leader node. As a Cribl deployment gets more complicated, there are more things for the leader node to think about, to monitor, and to consider. When you are expanding your edge deployment, please consult the sizing guidance that's available on our docs for how to adjust the size of your leader node to account for a scaling deployment. You'll need to scale it out for both an increase in the number of edge nodes, but also an increase in the number of fleets that you are managing as well. We've talked about how you would scale your architecture from a control plane traffic perspective. We're now going to think about fleet management from a logical control perspective. The first thing to think about are designing fleets. Fleets are logical groupings of edge nodes, and these fleets can have subfleets within them. Each subfleet can in turn have a subfleet within it, should you wish. The reason why subfleets are useful is they inherit changes to the parent fleets. So if you wish to make a change that impacts, as an example, all of your edge nodes on a specific operating system, if you have a parent fleet which contains all the subfleets for that operating system, you can make a single change that's then inherited downwards. This is a very powerful thing to think about and dramatically simplifies administration. When expanding your edge deployment and thinking about fleets, there are a few things to consider. Firstly, you should consider how many levels of subfleet you are planning to create. We recommend no more than 2 levels of subfleets below your top level. Additionally, when thinking about growing the number of fleets and subfleets you are managing, you can create a total of 50 fleets today. This is a soft limit, which will increase to 250 in the 4.16 release. If you are thinking of planning a deployment that has a very large number of fleets, please consult your Cribl account team for more tailored advice. Another point to remember is you can override inheritance. If you are making a change to a subfleet that impacts a setting, a source, or a destination that you've configured at the parent fleet level, this will override that inheritance. Finally, we would advise you not to use the default fleet and leave this empty for any fallback activity. This is useful for operations when any node ending up in the default fleet could be an indicator that your mapping rule set is not operating correctly. So when you are setting up your default fleet, please disable all of the sources and all of the destinations so it's essentially operating like a blank slate. Let's talk about how we decide how a node ends up in a specific fleet. This is managed using mapping rule sets. Rule sets allow you to decide which fleet specific edge nodes will join, and there's a very clear priority order for this. The first thing a leader node considers are its own mapping rules. These are logical expressions that are evaluated sequentially to determine which fleet a node should be placed in. The second thing being considered is the expression of interest that an edge node creates when attempting to connect to a leader node. So an edge node can state that it wishes to join a specific fleet as a variable it passes, but again, this is considered at a lower priority than the mapping rules itself. Finally, if none of the criteria apply, the edge node will be placed into the default fleet. When thinking about what parameters that you can use to determine where nodes are placed within your mapping rule set, I'd encourage you to have a look at the edge node info view within the mapping tab. This lists out a large number of parameters that you may wish to consider for determining which nodes are placed into which fleets. For example, you may wish to have a fleet that is looking for Windows OS, or you might have fleets that are conditional based on specific characters or prefix strings within your host name. For example, it might be the case that all servers starting with PRD for production should be placed into a fleet that is containing all of your production workloads. It could be the case that you are looking for specific connection IPs. So if you have multiple environments, each with their own IP address ranges, that's a parameter that you use for considering which fleet a node should be placed in. We're quickly going to go over a series of other tips. So these are things that are good to consider when expanding an edge architecture, but didn't neatly fit into either of the topics I've covered previously. The first thing to think about is using the Cribl API. This becomes more important as your edge deployment grows and it becomes more complicated. You can query the Cribl Cloud API using any of your favorite development tools to do so. And an example API call you could make would look something like this. So this is a call that I am making to get some information about which edge fleets I have set up within my deployment. I could then make a series of additional requests to enumerate which edge nodes are contained within each of these fleets and what their status is at any one point. This is really useful if, for example, you're working with a CMDB and wish to do periodic reconciliation between what you are seeing within your Cribl deployment and what you are seeing within your other sources of truth for assets within your organization. The next thing to think about are workspaces and role-based access control. There are a few circumstances under which you may wish to put different fleets into different workspaces. This can be useful for testing, for example, any changes to mapping rule sets, but also for managing access as well. If you are managing access, you can do this at a fleet-by-fleet level, in addition to any workspace level controls you are applying. To do this, go to the Fleet Settings option, go down to Access Management and view the Members and Teams option. At this point, you can grant additional levels of access to people within your organization to meet your specific requirements. You could, for example, have specific server owning teams having read-only access to the edge nodes within a fleet that maps across to their servers that they manage. Alternatively, you could do a self-service model where certain application teams make changes to the fleets that could also include source and pipeline modifications as well. When we're thinking about access and inherited permissions, inheritance isn't just within fleets for configuration. It's also important to think about for permissions as well. Permissions in Cribl Cloud are additive and inherited. For additive permissions, if there are two reasons that a user or team should have a level of permissions, the most permissive is considered. For inheritance, if permissions are set up at the organization or workspace or product layer, they're inherited downwards towards individual worker groups or fleets as well. What this means is if you've given someone a workspace administrator role, they will in turn get product level administrator access. And when we are thinking about a scaling deployment, you must consider, are your Cribl stream administrators the same people as your edge administrators? It might no longer be appropriate as your deployment expands to give everyone the same high level of permissions. So to use that example from the previous slide, I had a team set up that I was focusing on creating for my Cribl stream admin groups. But these individuals had a very high level of permissions granted to them. So you can see I gave them admin access to every single Cribl product. A more selective application of permissions could be retaining their administrator rights on Cribl Stream, but only granting them user level of permissions for Edge. This would enable them to continue with the work they're doing, but grant them only the access into Cribl Edge as and when they need it. The final piece of advice that I would share from today is to consider doing the Cribl Certified Edge Admin course. This is a course that builds upon the concepts and content presented within the Cribl Certified user, really looking at how do you manage Cribl Edge in a scaling deployment. The course takes about a day and a half to complete and is available as and when you choose to take it. If you do complete the admin certification, please do share this with all of your Cribl colleagues. It always brightens our day to hear about that. For some extra resources and staying in touch, please do come and join us on the Cribl Community Slack channel in #EMEA. We're available on Slack. We have a great supply of documentation available, and there's also more Cribl U content coming later this year. If you would like to reach out to the Cribl customer success team, you can reach us at success@cribl.io. I hope you found today's presentation about Cribl Edge useful. If you have any questions, please do join us on Community Slack in #EMEA. Thank you for your time.